So we're live from the 2015 Robotics Leadership Summit at GE's Global Research Center in Niskayuna, New York. We're here with Eric Nieves, who has been building robots for more than 20 years and is the founder of PlusOne Robotics. So Eric, first of all, thanks for taking the time to speak with us.
Glad to be here, absolutely.
So today you're basically about to give a talk on human-centric robots. What does human-centric robots mean? And so kind of give us some of the key highlights of the talk.
So there's a lot of talk in our industry of human-robot interaction or collaboration. And human-centric robotics takes the view that in the human-robot relationship, it's not the robot that's exceptional, it's the human, right? Human capabilities far exceed those of robots and PCs and algorithms and everything else. So there's lots of things that we do inherently in our perception and our cognition, our decision-making, our intuition, our intention that robots are not good at. So it's how we're going to knit those things together, right? The real value that we bring as people and how we kind of offload some of the heavy lifting to automated pieces of equipment and marrying the best of both worlds. That's what PlusOne is about.
So how's this technology evolving right now? Where are we at, and how do you see it kind of stepping, say, 5 years into the future?
Well, I can tell you that 5 years ago, we weren't in a position to really be talking about this now. The reason that this is even possible, let alone probable, and really no way to stop it at this juncture, is because of the ubiquity of connection, right? Anytime you're going to have an interaction, you have to have connection. So the fact that all of the equipment moving forward, every piece of it is either going to be Wi-Fi enabled or have an Ethernet port. All of our factory assets are going to be connected in a way that we can access them, we can interact with them, we can put software layers on top of them and cause them to do things differently in a reactive mode than they have been by their rote prescriptive sort of memory that they've been working in now. So that's really one of the first enablers, and that's the reason that I'm so excited about the work GE is doing. Industrial internet is in some ways the infrastructure required for human-robot interaction at scale. Secondly, sensors. Sensors are becoming ubiquitous and low cost. I would love to say that it's because us robot guys, needed it and wanted it, so we made it. But the fact is, the robot industry is quite small, too small to attract any to drive our own development. So we ride the coattails of others. And for the past decade, that's been consumer electronics. And what consumer electronics has afforded us as automation people is many sensors at low cost, but with high performance. So that's another one of the elements that's been brought to bear that's helping us move forward in human-robot interaction.
Where does the brains or the software fit into that? You mentioned sort of the hardware pieces.
Right. So the traditional view is that the robot controller has to have all of this intelligence built in. And there's lots of people working on that. That's the whole notion of AI. And it runs the gamut between soft AI and hard AI. And, what are the limits? Regardless of what the limits are, we take the view at PlusOne that effective artificial intelligence is decades out. And do we really want to lose 10 or 12 or 20 years worth of productivity between now and then when we have wonderful intelligence available to us? It just happens to be in biological form. So it's making the connection between human asset and robot asset seamless is really where the value is and where the cognition remains. The robot doesn't have to get smarter if it's connected to smart people.
So based on that, and that viewpoint, and the idea that any concept of cognition or a deeply somehow thinking machine is way far off, how do you see it looking with the type of machines that you're working on and that you're looking at connecting in the next 5 years, 10 years?
Right. So in the next 5 years, I think you will see many instances of force multiplication, where you have one person who has cognition and perception inherent attached to many robots distributed who knows where. Maybe they're local to the facility he happens to be working in, or maybe they're robot diaspora spread all over. And yet, whenever a robot runs into a situation that it doesn't understand, it raises a flag over the internet and says, hey, I need a little direction here. The key is the robot is quite capable of its own volition. It can do meaningful work on its own most of the time. If it can't do that, don't start with the robot. Leave that as a manual operation. But that's not the case. A lot of applications, the robot is beneficial. It just can't do everything. So, unfortunately, to date, what that's meant is if it can't do it all, it can't do any of it, just leave the robots out of the equation, and the user doesn't get the benefit of automation at all. But instead, by marrying them to the human, you're able to have the robot do what it can by itself, and then when it needs help, this remote robot wrangler says, oh, somebody's having a problem, or this machine is having an issue. I see the problem, I correct the problem, and it goes on with life. Right? So that's what I see happening in 5 years. In 10 years, what I expect is we're going to stop talking about robots. I really believe that. We talk a lot about robots now, and it's a good thing. And we start talking about robots early. You've got youngsters dealing in robot clubs, and middle schools, and high schools, and first Lego leagues, and all of this. So we have a whole culture now that knows robots and accepts them. That is a sea change in America. But like anything else that we have in any sort of ubiquity, it begins to dissolve into the background. I believe we will have robots right when we stop talking about them. That's when we know we got the automation as it ought to be, is when it recedes into the background.
So what role is PlusOne playing in this future that you're bringing up?
So PlusOne is going to bring to market this interface that allows the connection of human assets, wherever they might be, and factory assets or robots, wherever they might be. Maybe they'll be together, maybe they'll be apart. That's immaterial. It's how do you bring human value to factory assets in a seamless way. That's what we're going to be doing.
So you talk about it in terms of, it sounds like, human in the loop, but almost human in the center.
Yes.
Of this connected world of machinery that's both smart, but also they connect to each other, they talk to each other, they produce data. What are the hurdles to getting, again, to that point from where we are now?
I mentioned that there are lots of connected robots out there, but just because a robot has an Ethernet port or a 4G connection to it doesn't mean it's listening. Okay? So that's the first thing we need to do. Secondly, we need to be careful in the applications we choose to have sort of this remote interface for. There are lots of robots doing important work in manufacturing today that don't lend themselves to this model, right? I think particularly of process applications where robots might be doing painting or they might be doing welding. Those are techniques and process that I have to have a lot of process expertise to be able to effectively manage from remote. So no, I don't think that, I think those are a hurdle. I think initially you're going to find this work is going to be much more amenable to material handling operations.
Such as?
Over half the robots sold today are doing pick and place of some variety. It's going to be picking up a part and loading a machine, or it's going to be taking a part off of a conveyor and putting it in a bin, or vice versa. There is a lot of labor in this country associated with just moving things. From a value chain perspective, not a lot of value there, right? Didn't get any more expensive. It didn't become any more important, this device that you just happen to be moving. Just needed to get done. That's a perfect place to apply automation. So that's what I anticipate that you'll see first is robots moving goods and moving materials in lieu of people. But it needs to do it in a robust fashion, which means it's going to be sensor intensive and it's going to be connected to remote supervision.
How much flexibility do we need to add in to get to that point?
Robots, from a manipulation perspective, are quite flexible. The flexibility that we bring, because we understand the intention, what we meant for the robot to do, that is the value that we're bringing by adding a human back in the loop. If I would say that there's another sort of risk and hurdle, and where there's a lack of flexibility, is the last mile, the hands, right? So robot grasping is a difficult and problem that a lot of people are spending energies working towards. Is there's a lot of geometry in the world that I can manage to handle with this 5-fingered device. Where is the 5-fingered device that I can put on the end of a robot cost effectively and robustly today? There isn't. So in lieu of that, how do I scope the work such that the hands I do have available to me are effective in the work? Right? So that's the challenge, is balancing the application to be done with really the tools available to me.
One more question. How much of that is the actual dexterity of the hardware versus, we were talking to somebody earlier that was saying, the computer vision part? When you actually grab something, you lose it.
Yeah. So, that's why there's so many people working on the computer vision part, because it's abstracted, it's generic. You see, right? Not to minimize that. There's certainly real challenges there. But, I can see a widget, I can see a box. Those are the same tools. But to pick up said widget or to pick up a box may be completely different end effectors, different hands. Maybe I can do it with suction for a box, but I have to have a grasper for widget X. What do? The current approach in automation is to just change hands. You just have a tool changer and you pick up tool A, tool B, depending on what it is that you're handling. That's not what we do, right? We have this very dexterous end effector that can handle all these different geometries. But we are a long way from solving that problem. This is a lot of degrees of freedom, and it's a lot of sensing. There's a lot of tactile, there's a lot of force feedback that we do inherently that just isn't there, technically right now. Today you can buy robot hands, but they are more expensive than robots. So the ROI is just not there today.
Eric, thank you very much for taking the time to speak with us.
All right, take care.